Alright, this week we were tasked with implementing a shadow calculation to modify the existing ray tracing code and to include shadows, to add a shadow ray from the intersection point to the light source and determine if the object blocks the light. And then if it does, adjust the pixel's color to create realistic shadows. Okay, so this was the textbook code rendered out using Java. As you can see, there's no shadows here. But if we run this, and it takes like 5 minutes to compile this, so I did it beforehand, we get these shadows using our implementation. Alright, so let's walk through this. Oops. Okay, so this is in the trace ray function. So my teammates are going to talk about this section of the code. We're avoiding the intersection of the shadow so that doesn't go right through it. And then, what's the other thing? Yeah, checking to see if it's intersecting. Today I'll be talking about this computing the color based on the shadow. So as you can see, our color space is in RGB. It checks to see if the area is in shadow, and then it does this cool little reflection. So it multiplies the RGB values by a half. The reason we do this instead of dividing by 2, we multiply by 0.5 instead of dividing by 2 is because multiplication is faster than division on computers. But this gives us half of the value. So I'll give a little demonstration, and then if it's not in the shadow, of course, we do this instead. So let's walk through this. I have a little demo here. This is a pyramid drawing that I just drew really quickly, and we're gonna have this shadow, but for the moment it's the same color as the pyramid. Now this this color, here we go. Okay, so if we take as you can see, they're the same color. If we take 248 and multiply it by 0.5, we get half of that as 124. So we put 124 in here. And 236. Oops. $118. Again, you're just dividing these by half, and then half of 62 is 31, but just for... And so this is what the shadow would look like. Now, one of the issues with this is that it's all in black and white. So, of course, these functions could have been because black and white, the red, green, and blue are all the same values. You could simplify this and have like 1 R equal to G and G equal to B, so that you're really only running this function once. But if, let's say, you did have color, then this is good for in the future. If you have an object that does have color, you want to get the correct values. Yeah, so some things going forward, we're kind of future-proofing our code by using RGB, even though the current object, everything's black and white. That will help us in the future.